Hello everyone. So I'm Kaushik Malik and today I'm going to discuss the first three problems of Codeforces Round 882. So let's begin with the first problem. The first problem states that Kars is tired and resentful of the narrow mindset of his villagers since they are content with staying where they are and are not trying to become the perfect life form. Being a top-notch inventor, Kars wishes to enhance his body and become the perfect life form. Unfortunately, N of the villagers have become suspicious of his ideas. The ith villager has a suspicion of AI on him. Individually, each villager is scared of Kars, so they form into a group to be more powerful. Okay, so the group of villagers are contiguous segments of an array from L to R, and the power of that group is calculated using this formula. That is, it is the absolute difference of the consecutive elements. Okay, and it is said that Kars wants to break the villagers into exactly key contiguous groups so that the sum of their powers is minimized. Okay, so what can we do in this case? In this problem, let's consider the first example. It is said that there are 4 villagers and we have to split them in a group of 2. Okay, and the power of them are 1, 3, 5 and 2 respectively. So if I split them into a group, let's consider this is the group, first group, then what will be the power? It will be difference between these two, that is 2, difference between these two, that is 3, and since there is only one element in this will contribute to 0. So the total power in this case is 5. Okay. So what can be another case? I can consider 1, 3 in a segment and then 5 and 2 in the other segment. Okay. So in this case the power would be 2 and this would contribute to 3. So the power will be 5. And in the third case, I can take 1, 3 and 5 in one group and 2 in the other group. So this will contribute to 2, this will contribute to 2 and this will contribute to 0. So the power, minimum power that we can obtain is 4. Okay. So what can we observe? We have to take the difference between the consecutive elements and take the lowest out of them as possible. So whenever I break a group like this, like 1 and 3 in one group and 5 and 2 in the other group, I can always omit this difference between the groups. So how many such difference can I omit? That will be equal to the number of groups minus 1. Okay. So what can I do? I can simply take the difference of all the consecutive elements, store it in an array and sort them. In this case, the difference between first and second element is 2, second and third is 2, and third and fourth is 3. And if I sort it, I'll get the same array. And I can eliminate k minus 1 of these elements. So what should I eliminate? I should eliminate the largest out of them. So in this case, since k is 2, I will eliminate 3. And I'll take the sum of the remaining 2, which is equal to 4. And this is how we can approach this problem. That is, we will eliminate the k minus 1 largest differences and take the sum of the remaining differences. So let's have a look at the code. So this is the code of the first problem. We are in this part I'm taking input of n and k and simply storing the input in the array ARR1 and taking the difference of the consecutive elements in array ARR2. Okay. So if I eliminate the k minus 1 largest integer from the ARR2 array after sorting, then what should I do? I should take the sum from 0 to n minus k minus 1 elements from that array. and whatever will be the sum, that will be the answer. So this was the solution of the first problem. So let's begin with the second problem. In second problem, it states that Jonathan is fighting against Dio's vampires miners. There are n of them with strength A1 to AN. Denote L, R as the group consisting of the vampires with indices from L to R. Jonathan realizes that the strength of any such group is its weakest link, that is the bitwise and more formally the strength of a group is given by the bitwise AND from AL to AR. Okay, so what we have to do? We have to break this array into the maximum number of groups possible, such that the bitwise AND of the sum of bitwise AND of all these groups is as minimum as possible. Okay, so what can we do in that case? So let's see an example in this case as well. Let me consider the second example. There are 5 elements and the elements are 2, 3, 1, 5 and 2. Okay. So what can we do in this case? Since it is said that I have to make the value of bitwise AND as low as possible, then what is the minimum bitwise AND value that I can obtain? I should take the AND value of all the elements in this array to get the minimum AND value as possible. Okay. So if I take the AND value of all these elements, let me assume that value is equal to P. Okay. And so can I break this array into smaller groups such that the sum of the bitwise AND of all this group is equal to P? It is not possible in this case, because if P is greater than 1, if P has a value greater than or equal to 1, and I break them into groups, let's assume in 2 groups, and both of them have a value, bitwise AND value of 1, then the sum I'll get equal to 2. Sum that I'll get of these 2 groups is 2, and the bitwise AND value cannot go below of any of these segments, cannot go below 1. So the minimum I could get is P, and the value would at min be 2P. So the best possible way is to consider the entire array, and the bitwise AND of that complete array would be equal to P. Okay. But there is a case. Let us assume that the value of P turns out to be 0. If the value of P turns out to be 0, then this won't hold true. Taking sum of values will not cause any difference, because 0 plus 0 would still give 0. In this case, the array can be split into multiple parts. So how should I split the array? So to split the array, I can start iterating from the first element and keep on taking bitwise AND of each element as I move forward. And as I get and after reaching an element, if the bitwise AND turns out to be 0, then I can simply start a new array I can start a new segment after that. Okay. So this segment sum would be 0, and if there is some segment after that, I can say that the bitwise AND of that segment might be equal to 0 or might not be equal to 0. So if it's equal to 0, then it might be the case that in that also the first k elements are contributing to make it 0. After that, again the remaining elements would still have 2 choices. Either the bitwise AND would be 0 or the bitwise AND would not be equal to 0. Okay. So if I break this array in such manner, and let me assume that I got 3 segments, and after that I got some element whose bitwise AND is not equal to 0. Bitwise AND of all the elements left over here is not equal to 0. So what can I do in this case? I should merge this element into any one of these groups, because bitwise AND of this group is already equal to 0, and if I add some more elements to it, it won't affect the answer. So in that case also, the answer would be 3, since these elements could be merged with this group. Okay, so let's see the implementation. So this is the implementation. First I've taken n and the array as input. After that, I've taken the bitwise AND of each element of the array. Okay, and if that value is equal to 0, then I need to compute how many subarrays I can break with bitwise AND equal to 0. Else the count will always be equal to 1, and after that I'm printing the count. And to check whether a segment has bitwise AND value equal to 0 or not, I can iterate from the start. I can take the AND value at each index, and if that becomes equal to 0 or temp, then I can increment the count, and since I'm again beginning with a new segment, I will initialize the val variable with integer.maxVal. And why the max value? Because in max, all the bits are set to 1, and taking AND with any number would become that number itself. So if I have some element after this index, that value would simply be equal to max value of integer, and that value which is equal to that same value. So this was the second problem. Now let's begin with the third problem. So the third problem states that Dio knows the Stardust clusters have determined his location and will be coming to fight him. To foil their plans, he decided to send out stand users to fight them. Initially, he summoned n stand users with him. The Ayat 1 have a strength AI. Using his vampiric power, he can do the following as many number of times. Let the current number of stand users be m. Dio chooses an integer I from 1 to m, and then he summons a new stand with index m plus 1 and strength equal to Zor value of from ith index to the last index. Okay, so the value of n given is 10 to the power 5, and the array elements can vary from 0 to 2 to the power 8. So what do we need to do? We have to find the maximum stand value of a user that we can create. Okay, so let's begin with the solution. Let's take an example. Let's take the third example. The array is 8, 2, 4, 12 and 1. Okay, let me assume that in first move I select this index as I, and m is my last index, and make the a m plus 1th member as the Zor value of all these elements. Let the Zor value of these elements be equal to p. Okay, so after that it will become equal to p. In next move, I decide to select this segment. Okay, so let me assume that the Zor value up to this last index from the ith index, from the new ith index, is equal to q. Okay, so what will be my next element? My next element would be p Zor q. Okay, so let's take another segment. Let's consider this segment as let's consider this segment for the next iteration, and the value of XOR from the starting index to the last index of the original array be equal to R. So what will be the third element? It would be equal to P XOR P XOR Q XOR R, and this is equal to Q XOR R. Okay, so let's take another segment, and this segment will start from this 4 and will go up till the end, and let the XOR of these elements be equal to S. Okay, so what will be the next element? It will be P XOR Q XOR Q XOR R XOR S. Okay, so this is simply equal to R XOR S. So what can we see? We can see that the value at each index is the XOR value of a continuous subsegment of the array. Like P XOR Q, P is this and Q is this. So P XOR Q would just be this element. Next element is Q XOR R, Q XOR R. So the value of Q XOR R would be equal to the XOR of these two elements. Okay, and the next element is R XOR S, R XOR S. So it will also be these two elements, XOR of these two elements. So what can we say? We can simply say that the value that we are looking for is the maximum value we can create by taking some continuous elements from this array and taking its XOR. Okay, so what can we do next? It has been given that the upper bound for the numbers is 2 to the power 8. All the numbers are less than 2 to the power 8. Okay, so the maximum XOR value that I could get is also 2 to the power 8. So what should I do? If I start iterating from 2 to the power 8 minus 1 up to 0 and check if there is one segment of the array that generates that value, let's assume X as the XOR value, then we can stop iterating and could print X as our answer. So how can we check whether whether the given XOR value exists or not? So we can simply use a hash set and prefix XOR, pretty standard algorithm. We can take XOR of 8 at the first index, XOR of 8 XOR 2 in the second index, then 8 XOR 2 XOR 4 in the third, then 8 XOR 2 XOR 4 XOR 12 in the fourth, and the last index would have 8 XOR 2 XOR 4 XOR 12 and XOR 1. Okay, and I create a set as well. I go to the first element and I'm iterating from 2 to the power 8 minus 1 to 0. So let me assume that I'm currently at X. Between these two values, I am at X. And I need to check whether a subarray exists whose XOR value equal to X. So I'll keep iterating from this first index and I'll look for the value of X XOR the current element I am at, that is 8 in the array. Because if my target value is equal to X and what do I want to make? If I want the value of XOR of this subsegment, let's assume that the XOR value from starting till this index is equal to A, and the XOR value up till this is up to this is B. Okay. So I want to find whether there is a subsegment whose XOR value equal to X. So we can simply write X is equal to A XOR B. Let us assume that this subsegment gives us the answer. The array elements between these on taking the XOR value would give X. So if I take X XOR A, then I'll be left with B. Okay. And if I find B in my set, which I was creating while iterating in forward direction, then I can stop and say that I can create the value X. And once I find the answer, I can simply break from this loop and print the answer. And the time complexity would be equal to 2 to the power 8 into n. And since n is 10 to the power 5 and 2 to the power 8 is 256, I guess. So that would be within our time. So let us see the code of the third one. So this is the code. We are taking the input array, and in ARR2 I'm storing the prefix XOR of all the elements, and then I'm iterating from 255, that is 2 to the power 8 minus 1, to 0. And as I said, I maintained a hash set to see whether the XOR value I'm looking for has already occurred in the array or not. And so I'm simply iterating from 0 to n and taking XOR of my target value, that is I, with this element at the current index. And if my set contains that value, then I can say that I found the answer, I can simply break out of the loop. Otherwise, I'll add the current element in the set as well and continue the iteration. And if I don't find it for a given value of I, then again I'll do I minus 1 and repeat the same process until I find the answer. So these were the solution to the first three problems. Thank you.